Move on to the next speaker. Thank you once again.
Thank you.
Next speaker is Izabel Alfany from LATAT. She will speak about Hyposense, which is a photonic project about breast cancer detection.
Yeah. Do you hear me? Louder. Okay. Thank you. Good morning. My name, as presented, is Izabel Alfany. I'm Business Development Manager at LATAT, Technological Center in Barcelona, Spain. And I'm here to present Hyposense project, which is not an MVP project. That's why I think it's in that session. And it's entitled Nano-Confined Photonic System for Detection of Breast Cancer Spread to Lymph Nodes. So our vision is a better, faster, more accurate, and less painful prognosis of breast cancer. And the mission is to design and to implement an innovative solution to improve breast cancer prognosis, and of course to help oncologists and patients in personalized medicine. Concerning the medical issues we are trying to address with this project, we are focusing the breast cancer because it's the most common cancer in women, and it reaches 1 million new cases each year worldwide, and with such a huge impact, I think it's important to go further in new technologies. As you know, cancer metastasis occurs when highly aggressive tumor cells escape from the primary tumor mass and travel through blood and or lymphatic systems towards the target organ. And in the case of breast cancer, metastasis occurs mostly via the lymphatic systems. The lymph nodes that are closest to the tumor are the most likely route for these cells to first reach and enter the lymphatic systems, and these nodes are called sentinel lymph nodes. Therefore, diagnosing the cancerous cells within the sentinel lymph nodes are critical for patient stratification, for an accurate prognosis, and also for providing an optimal treatment plans for the patient. Currently, the malignant breast cancer is stagged via only sentinel lymph nodes biopsy procedures, which is a highly invasive surgical procedure. Requires also clinical personnel, high skilled. It's quite expensive, and also it takes about 2 weeks for render any result. And with this all negative impact to patients and to oncologists and the public health systems, we are trying to improve the environment here. Our solution, the Hyposense technology, as you can appreciate here with this tiny scheme, is a unique optical cancer prognostic system that determines, as I mentioned, presence of cancer cells in the lymph nodes. And it's composed by the nanocapsules, which are functionalized with antibodies that recognize and target the cancer cells. These nanocapsules are also filled with oxygen and temperature sensing molecules, which are 2 parameters quite relevant for clinical identification of metastasis. And the systems is also composed by a non-invasive near-infrared imaging device, which will process all the data collected by the injected nanoparticles. Why our solution is unique and has a chance to work? Firstly, because Hyposense is based in a solid demonstration, experimental demonstration proof of concept of the device and also the nanosystems. And also because such a low cost, easy to use, safe and non-invasive imaging technique can accurately and precisely detect, diagnose metastasis in breast cancer in real time. And currently there is no real-time solution also for early diagnostics in this type of cancer in the clinics. This project started just 1 year ago, so I don't have clear results for show you today, maybe in the next year. But from this table, you can appreciate that indeed we are taking the components of the technology from TRL 3, proof of concept level, until the level 6, demonstrating the systems in preclinical in vivo models, and also with human samples, ex vivo models. Our next steps, the initial target of the project is breast cancer, but with such technology, it won't be that complex to translate it to other types of cancer and increase the market impact, such as vulval, colorectal, gastric cancers. And also, of course, helping a significant decrease in the diagnostic associated with metastatic cancer progression. Here you can see the contacts of the scientific coordinator of the project, Dr. Frances Michans, head of the Health and Biomedicine unit at LATAT. So he's the one who is able to answer to real technical aspects from this project. You have also my contact here. And you can also appreciate the powerful consortium that make it happen, the development of this project. Thanks to these guys all. And before finishing, if you allow me, I'd like to take the chance and invite you all for the workshop that the GLAM project is organizing, entitled Key Enabling Technologies for Better Cancer Diagnosis, the 7th of November in Tel Aviv. Is an event with a really high-profiled speakers. I invite you to connect to the webpage and check the quality of the sessions there. It's free for charge, so you just have to register and come to the session. So thank you. And that's it.
Thanks a lot. We have time for 1 or 2 questions. At the back, if you may. Hey, one question from the Pope of...
We should have sat at the front, you're right. I was going to ask, there are, of course, systems out there for sentinel or lymph node diagnosis, non-invasive methods. And are you thinking of how your system is going to compete with those systems which are on the market, really?
Yes, we listed it. It's already exhibit in our project. We are talking also to the companies that have. The thing, if I'm not wrong, is not a technology that can detect in early stage of the metastasis here in the lymph nodes. That would be the differential aspect from our technology.
Another question? Okay, thank you very much. So we move on to the next speaker, and I'm inviting Lorena